Now you're gonna measure where the fire is.
5.5. We are on page 437. 437. 5.5 law of sines. This will be part 2, I believe. Example number 4 or 5? 4. Example number 4. All right, Forest Ranger Chris Johnson at Ranger Station A sights a fire in the direction of 32 east of north. East of north, so 30. So this is north, and it's 32 degrees east of north, so it's this way, 32 degrees, and this is Ranger Station A, where Chris Johnson is located. Ranger Rick Thorpe at Ranger Station B, 10 miles due east. So 10 miles due east, this is 10 miles. And from B, Ranger Station B sights the same fire at 48 degrees west of north. So this is north, and we're gonna go 48 degrees west of that. So it's gonna look like this. So this is going to be 48 degrees.
Okay.
So the fire is going to be right here. And we need to find out what? We need to find out the distance from each ranger station to the fire. So I want to know this distance and this distance. So basically what are we doing? We're trying to solve this. If I call this C, we're trying to solve the triangle, correct? Really? Is that what we're trying to do? So this angle is what?
58.
58. This angle here is 42, right? Which will make this angle what?
90.
Wait. No. That's
80. 80. Yeah.
80.
I was adding when you said 90.
Okay, so if I call this B and I call this A, I can say that sine 58 over A is equal to sine 80 over 10 is equal to sine 42 over B, correct? So I know all three of these, so I can use this here to solve for A, this here to solve for B, right? Okay. I'm not going to go any further. You understand what's going on here, right? Okay. All right. Okay, so that's that. Example number 5. Example number 5 is a little more complicated. Example number 5 is a shadow question, which you guys have been doing since mid-high math. But there's a little twist. There's a little twist to this one. Okay, example number 5. A road slopes 10 degrees above horizontal and a vertical telephone pole stands beside the road. So the angle of elevation to the sun is 62 degrees. Okay, so we have 62 degrees. So I have a road that is already sloped 10 degrees. And I have a telephone pole that has an angle of, this is 62 degrees. And I'm trying to find this length here, from here to here, right? I'll call this, whatever.
Shadow.
So, do I know this angle here?
We might. Yeah.
This is A, B, and C. What is that angle?
138. Wait.
Well,
No. I was reading that wrong.
Because this here is 90, right? So this plus this must be 90. So it'd be
28.
28.
Wait a minute. Okay. It's not my day today.
That's okay. So if this road was flat horizontal, there was no slope to it, this here would be what? This angle here would be 90 degrees, right?
Yeah.
But it's not. it's 10 degrees slope. So this guy is no longer 90, it is
80.
what?
What?
Come on.
Listen to King. He's wrong.
Because if it was here, this would be 90, and I'm adding 10 more degrees,
Yes.
right?
Ah,
10 more degrees. Okay.
if you did it the other
So this guy is
way-
gonna be what?
Oh, if we go down. Yeah, then we go.
52.
I blame it on you.
52.
Oh my God.
And I know, what do I know? I know that the pole is what?
10 feet.
I don't know.
No.
14 and a half.
It says
Oh, that's
Pole
the shadow.
casts a
we're
14.5
checking the height of the
shadow. So this is
telephone
14.5.
Find the height.
This is 14.5, and I want to know the height of the pole,
Who measures the shadow?
right?
Why does the shadow matter?
pole. I feel like it'd be easier to measure a telephone pole than a shadow.
So you want to have somebody climb all the way up to the pole and drop you something down?
Yeah, sure.
Isn't it easier to just measure the shadow?
Well, it depends on how.
Why do you
tall
need to
the
know
pole
how tall a telephone pole is?
Huh?
Why do you need to know how tall a telephone pole
Well, there were several reasons.
Okay.
Explain
If let's say you have a telephone pole that is 90 feet high.
Yeah.
Do you want to build a house that is 60 feet close to it?
Yes. So when it falls,
So when it falls right on your house?
But then it doesn't break. Then
Even
it,
though it depends on where you live.
you
What
just
do you
eyeball
mean? It depends on where you live.
it. You just eyeball
There's
it.
wind where you live.
What's another reason, Mr. Rowe?
Huh?
What's another reason?
I feel
What's
like you
another
like
reason?
question
It's
through,
the same thing. If you're gonna build I don't know, you want to make sure that if these falls, that things are clear away from it as much as you can.
Why would they fall though?
Why would telephone poles fall?
Is it
Telephone poles fall? I don't know. Hurricanes?
Just, just don't have a hurricane. It's simple.
Okay, so let's go back to this triangle. I know that now sine 28 over 145, 14.5 is going to be equal to sine of 52 over the h, right? Because this guy and this guy, right? So we solve for
Yeah.
h. All right, so that's that.
Oh, I see what you're saying.
24.3.
So we are done. Ooh. So we are done with that section.
Second